these notes are going to go over the integer rules that you should have learned from 6th and 7th grade. Some of you may remember them, others of you may need a refresher. Along with each rule that I'm going to show you, I'm going to give you some steps to help you get to the answer and some little tricks to use visual wise to help you understand and remember what you're doing. All right, so the first thing we're going to talk about is how to combine integers with like signs. And by like signs, we mean they're both positive numbers or they're both negative numbers. And by combining, we mean adding or subtracting depending on what the problem is about. Right? But in order to do this, there are 3 steps that you must take into consideration. The very first thing you must do, if there is this there, is to eliminate double signs. Eliminate means to get rid of. So eliminate your double signs. Always get rid of those double signs, because the more signs you have in the problem, the more confusing the problem becomes. The fewer you have, the easier it is to understand what you're doing. After you've eliminated your signs, you want to rewrite the problem, because it's now going to look a little simpler and easier to do. And then the third step is how you're going to get your answer. Right? So with like signs, that means 2 positive numbers or 2 negative numbers, we are going to add the numbers together and keep the same sign. So if it was 2 negative numbers you were adding together, your answer would still be a negative answer after you added them together. Right? So with this section, after each set of directions or rules, I'm going to help you with some examples and remind you of what you should be understanding from each section. Right? So for example, we're going to go back to bare basics with elementary school for a minute. Okay, positive 3 plus 9. Both numbers are positive, so that's like signs. That means we're going to add the numbers together. 3 plus 9 is 12, and because both numbers are positive, then that means the 12 is going to be positive. Okay. All right, for the second one, if we have negative 4 plus negative 7, right? This is where your double signs are going to pop up. A double sign is when you have 2 signs with no number in between them. So if you look at the problem, this plus and this minus sign right here, okay, are double signs. There's no number in between them. A piece of a parenthesis does not count, right? So in the world of math, a positive and a negative change to a negative. So when you rewrite this problem, which is what step 2 says to do, you're really using the problem negative 4 minus 7 so that it doesn't have extra signs. Now because both numbers are negative numbers, they're like signs, we're going to add the numbers together. So 7 plus 4 is 11. And because both numbers are negative, the answer is going to be negative 11. Okay, so just be careful as you're looking at your numbers and your signs and make sure you're understanding what's going on there. All right, a third example would be if I have negative 6 minus 17. There are no double signs. Okay, so I know both numbers are negative. If I cover up the negative 17, I still have negative 6. If I cover up the negative 6, it leaves me with negative 17. Be careful. Minus signs and negative signs are one and the same depending on how you're looking at them. Right, so we're going to add the 2 numbers together. 17 plus 6 makes 23. And because both numbers are negative, the answer is going to be negative 23. All right, for number 4, all right, let's take a look at a last example here. And then I'm going to show you something that's visual that can help you out with all the adding and subtracting problems. All right, actually all the integer problems. It works for everything. All right, if we have 11 minus negative 3, you'll see that there are double signs here. Okay, 2 negatives. Right, are going to turn into a positive. So when we rewrite this problem, it's going to say 11 plus 3. That means both numbers are positive numbers. And when you add them together, 11 plus 3 is 14. And since both numbers are positive, the answer is positive 14. All right, now some of you may have been exposed to these little faces before, but the faces will help you through add, subtract, multiply, and divide with integers. So I want to take a moment here before I go any further and show you those faces and make sure you understand what's going on with them. All right, there's 4 of them, so go ahead and draw yourself 4 faces. And in these faces, between the eyes, the nose, and the mouth, you can see all the integer rules happening, right? So for instance, if you're awake, your eyes are open, those are 2 positive numbers, okay? That means that you're going to add the 2 numbers together, okay? And then that makes you happy when you're awake, okay? So positive thing is a good thing. So 2 positives will make a positive. If you have 2 negatives when your eyes are closed, we're sleeping, which is also a good thing. So we're happy about that too, right? And because 2 negatives are making us happy, then we're going to add the numbers together to get our negative answer. Right? In multiplication and division, it'll look a little different though. But these faces, the nose tells you what you're going to do operation-wise or what your sign is going to be for the answer, depending on which one you're trying to do. Right? And then if somebody punches you in the left eye and your right eye is still open, that's a negative thing. We're not happy about that. Right? So that produces a negative or a subtraction sign, depending on what you're using it for. And then it's, let's say it reverses and your left eye is open, but your right eye is swollen shut. We're still not happy about that. That's still a bad thing. Okay, so use these faces to help you decide what to do and what your answer should come out with in terms of signs. They are very beneficial. All right, there are some other ways and memory tricks to use. So if you were taught something in the past in addition to these or different than these and it works for you, then please feel free to use it. All right, so now that we've done combining with like signs, let's talk about combining with unlike signs. All right, and the word unlike signs just means different. So one number's positive, one number's negative. All right, so before we do some examples, again, we're going to go through the 3 rules to get there. Just like last time, you always want to eliminate your double signs first. Remember, again, that gets rid of them. And your faces will help you eliminate those double signs. If you look at your faces, 2 negatives turn into a positive. That's what the nose is for, right? So it helps you do those eliminations. And because you've eliminated signs, you do have to rewrite the problem. And step 3 is where things are now a little different. With unlike signs, or different signs, you're not going to add the numbers. Now we're going to do the opposite. We're going to subtract the numbers. And keep the larger sign. So whoever is the biggest number-wise, whatever sign's sitting in front of that number, that's the one you're going to keep. All right, so let's take a look at a couple of examples pertaining to this one, and then we'll switch to multiplying and dividing. All right, so the first example would be if I have -7 plus 13. Right? I have a -7 and a positive 13. That's different signs. That means I'm going to subtract the numbers. So 13 take away 7 is 6. Okay, and because 13 is the bigger number and it's a positive 13, my 6 is going to stay positive. Okay, there were no double signs in that problem. Right? For number 2, if I take 24 minus 15, this is just a normal problem that you've been doing since elementary school, right? Again, a positive 24, a negative 15, that's 2 different signs. So we're going to subtract the numbers. 24 take away 15 is 9. Because 24 is the bigger of the 2 numbers, it's a positive, so the 9 stays positive. All right, so for number 3, if I have 7 plus -16, okay, I have double signs, so I'm going to take my double signs and I'm going to get rid of them and rewrite the problem. So this is really going to say 7 minus 16. Okay, I have different signs. It's a positive 7 and a negative 16. So I'm going to subtract the numbers. 16 take away 7 is 9. All right, but because 16 is the bigger of the 2 numbers, in front of the 16 is a negative sign. So that means my answer is -9. Okay, so you've got to see who's the biggest one and what kind of number are they to determine whether your answer is positive or negative. Okay, and then the fourth one here would be -3 minus -10. And once again, I do have double signs, so these 2 negatives are going to turn positive. So I rewrite it to say -3 plus 10. Now you can see that I have the different signs, a negative and a positive sign. So I'm going to subtract my numbers. 10 take away 3 is 7, and because 10 is bigger, then the 7 is going to stay positive. Okay, so hopefully those were just a reminder of what to do with your integers as we add and subtract them. Okay, the next thing we want to focus on are multiplying and dividing. Now the nice thing about multiplying and dividing integers is that the rules are exactly the same for both. The only thing that's changing is the fact that you're either multiplying the 2 numbers together or dividing the 2 numbers together. Right? So here's how straightforward as it becomes. If you have same signs, you will always have a positive answer. If you have different signs, or unlike signs, a positive and a negative, you will always have a negative answer. So once you know that trick, the multiplication and division part becomes really easy. The only thing we have to watch out for is when exponents get thrown in here, and I'll show you a couple of those. All right, so let's take a look at a couple of examples here. If I have -21 divided by 3, and remember that we will not be using the elementary division sign that looks like that with the 2 dots on it. Okay, we use fraction bars or division bars now, right? And that's what you need to get used to seeing. So negative divided by a positive is going to be a negative answer, and 21 divided by 3 is -7. Okay, and then if I have something like -84 divided by -3, I see 2 negatives in division, so that means my answer is going to be positive. And then if you divide 84 by 3, you'll get positive 28. Okay, so those are 2 division examples. Now let's take a look at some multiplication examples. Right, for multiplication, if I have -6 times -9, if you see 2 parentheses side by side like this and there's no dot or anything in between, that means multiplication. We do not use an X for multiplying anymore, so please do not use that. That is now a letter. A negative times a negative is a positive. 6 times 9 is 54. So your answer to that one is 54. Okay. If I have something that's written like -11 times 3, if you don't see parentheses, then a dot is what you're going to see. A negative times a positive is a negative. 11 times 3 is -33. Okay, so those should be things that you are pretty well versed in. Now, where things might get a little different for you is when exponents are involved. Right? So we want to take a look at a couple of these because exponents are still part of multiplication. Right? If I have in parentheses -4 and then squared is on the outside, what this means is that I'm taking -4 times -4. So 2 negatives are going to create a positive, and 4 times 4 is going to equal 16, positive 16. If you don't have those parentheses in there, things are a little different. Okay. If we have something that looks similar but has a different exponent, if I have -7 to the 3rd power, where the -7 is in parentheses, then this is really saying -7 times -7 times -7. Okay, and you take 2 numbers at a time. Negative times negative is positive. 7 times 7 is 49. Now I take the 49 and multiply it by another -7. Positive times a negative is a negative this time, and 49 times 7 is going to be -343. Okay, so do be careful, right, with your exponents and your negative values that you're looking at. Right, then the last section we're going to take a look at and deal with that pertains to integers are anything that pertains to absolute value. Now with absolute value, there's an actual definition behind this, right? In your actual definition for absolute value, many of you probably have it memorized by now, but if not, this is something you need to learn. Absolute value is the distance a number is from 0 on a number line. So if you have your generic number line and you've got your negative numbers, your 0, and then your positive numbers, right? It's how many spaces away is that number from 0. That's why our answers tend to come out being positive, is because you can't be negative spaces. You're just counting, right? But there is an instance where a negative can show up, and I will show you one of those. Right? So here are some examples for us to look at. Right? If I take the standard absolute value of -9, and do make sure that your absolute value bars are longer than your numbers. Right? They should not look like ones. They should be long enough that it looks different. Okay, so -9 is 9 spaces from 0. Okay. If I have this example where I have -17 in absolute value bars and then there's an extra negative on the outside, you do not have double signs here. Double signs only exist when you have parentheses. You cannot break through the bars of the absolute value. It's kind of like jail. You can't get out that way. Right? So you have to do the absolute value of the number first. So the absolute value of -17 is +17, but then the negative sign that's outside that bar goes in the answer, and that makes your answer negative. This is the only time when your answer to absolute value will ever be a negative number. Okay, so when that negative's on the outside, it travels over to the answer. Do not do double signs with that. All right, so if we want to look at doing some actual math with absolute values, if I have the absolute value of -8 minus the absolute value of -2, okay, again, do not do double signs. You can't. You have to do the absolute value bars first. So the absolute value of -8 is +8. Bring down the minus sign. The absolute value of -2 is just 2. So now you've got the math problem of 8 minus 2, and that makes your answer +6. Okay, so be very, very careful with those. And then let me show you one that involves multiplication, just so you can see that you can still do this too. If I have 4 times the absolute value of -5, in absolute value bars. Okay, you cannot multiply first. You have got to do the absolute value first. So it's going to stay 4 times the absolute value of -5 is +5. So now 4 times 5 is 20. So that's your final answer. So we will be using all of these integer rules in class. You will be able to use the assistance of a calculator, but the stronger you are at these, the easier things are going to be for the rest of the school year in terms of what we do in class. All right, so just make sure that you're up to date with them and that you understand the gist of where they're going. Okay, and we will take and go from there.